Guys, take a look at what you see on the board there.
What was the homework number?
Last night, 20, I think. Might have been 21, either one. That's good, I won't even look at that anymore. All right, so, guys, there's the answer to do it. Take a look, see if you agree. Remember, the function g of x has a a vertical shift of down 1. Hey, are you guys heading the game here? Right, the g of x function is the original f of x translated or shifted down 1. So, that is what I do. Okay, and the g of x is shifted left. Oh boy. I should have shifted to the right too, and I shifted to the left too. See how I didn't reverse it? Mm-hmm. I screwed up. H of x should be 2 units to the right. So make sure on your paper it moves to the right and not to the left. Yes?
Like instead of doing it like, because you did it like 0.5, then it goes by 0.5. So
Oh, yeah, I thought every mark was 1
okay.
rather than 0.5. Yeah, so there's 2 stupid linguist mistakes for today, of which I am so good. Talk to me now for a second about who's not here. Evan's not here. Kristen, Jordan.
A bunch of people are.
Yeah, they're all at lesson.
Yeah, anybody else not here? Everybody else look good. What was that, AJ? Yeah, there you go. All right. So, all right. Next up. So again, the h of x should be shifted 2 to the right, and I also made the mistake of thinking every box was 1 unit instead of 2 units, and that's actually, I'm kind of glad that I made that mistake, because what that means is that I can make the mistake before you do on your state test or your Regents exam, because they love to put little stupid, I mean, what's the point? But they do that because they really do enjoy tripping you up and making you lose little points. It's nothing that should make anybody fail the Regents exam, but it's enough to make you not get a 90. And the thing about this test is it's a tough test to get a 90 on. And little mistakes like this are, without a doubt, the kinds of things that trip you up. If you make 4 or 5 of them on a test, it becomes increasingly unlikely that you will get a 90. I am just putting your grades into eSchool at the moment. I have 1 or 2 more to type, and then I will. There you go. I'm done. So, all right. Now, all we're going to do for the course of the rest of today is some more translations and so on and so forth. Let me call it up here, get rid of the scanner. Something very strange is going on my computer. It says here that any scans should go to desktop, but they're not appearing on desktop. I think I got to reboot my computer to correct that. All right, 22, translating functions 3. And we just did the do it, which I will redo for the next class. All right, study the graphs below. Identify the parent function and the transformation of that function depicted by the second graph. The parent function is the one in red, okay? And then write a formula for the transformed function. Do that now. I'll give you less than a minute to get that done, because you should knock this out of the ballpark after 2+ days of doing this. Okay. Now. All right, so the red one becomes the blue one. And there's a component that's a horizontal shift and a vertical shift. And I just want to note one other thing here that is worth seeing. I wanted to bring this up for a couple of days. Do you notice how with a parabola, if this is the vertex, it's 1, and then 3, and then 5 until you get back on a perfect point? And it's the same on both sides, 1, 3, 5. I just want to talk for a second about why that is. One of the things I love about mathematics, and I think I started mentioning it yesterday, was the idea of there being order in the universe, and there being a consistency to how things are done. Things that defy coincidence. So what's 1 squared? Or what's 0 squared?
0,
1 squared.
1,
2 squared.
4,
3 squared.
9,
4 squared.
3,
5 squared.
3,
Now, if you look, that's a difference of 1, 3, 5, 7, 9. And if you add 11, the next one, you get 36, which is what you wanted. Then it would be 13, which is 49. And those are the perfect squares. And there's a difference of odds. So if you look here, this is like the beginning point of the parabola. And then whether you did the negative squares or the positive doesn't make a difference. It's 1, then 3, then 5. The next one would be 7. So as long as there's no number in front of the y equals x squared, as long as the coefficient is 1, then it'll always be 1, then 3, then 5, and so on. So that's a quick way to sketch the graph. If for any reason you ever see a parabola that doesn't go 1 unit up over here, up 1 over 1, and instead it goes 2 units, then you know you're multiplying by 2. If it goes 3, then you're multiplying by 3. If it comes out here, you're multiplying by 1/2. Okay? So that's not something that every kid is really going to realize, but it is a true thing that's observable. So one of the things that I like to do is look for that. I like to look for the up 1 over 1 here, and then the up 1 over 1 on the blue, and that means to me that I'm not putting an A in front. I'm not putting a lead coefficient other than 1. Now, this clearly goes, and I just checked to make sure each box was equal to 1, 3 to the right and up 5. So if I go 3 to the right, remember, first off, I have to have y equals. 3 to the right, reverse it in the parentheses, and then the vertical shift is up 5. So it's y equals x minus 3 squared plus 5. Okay, any questions? Looking good? How many people got that right? All right, I'm looking at a little less than half the class. So we should be nailing that. After 3 days, that should be a question that you are comfortable with.
Wait, isn't it x minus 3? Because you have to.
I did say x minus 3, because you go 3 to the right.
No, you said plus 3.
No, I didn't, I said minus.
You did say minus?
Yes,
I'm blank right now.
that's all right, I forgive you. It's the testosterone, I suffer from it too.
Testosterone.
Yes. Okay, so the next part, I'm not actually gonna fill out the table with you because we've already begun talking about this. Everybody take a look at the table here, ready? Hey, what do you notice about what's happening in each of these transformations? Is there any vertical shift? No. Is there any horizontal shift?
Yes.
Anything in the parentheses moving, changing? No. What do you see?
It's getting wider.
Right, you're seeing a coefficient other than 1 in front, which has the effect of making it, I hesitate to say the terms wider. What it does is it really makes it taller. Like if this is y equals x squared, then I know we like to say that this makes it more narrow to do y equals 2x squared, but what it does is it takes every point on x squared and doubles its value. So it's making it taller faster. Likewise, if I had y equals the square root of x, if I multiplied that by 2, that one actually comes out wider, whereas the previous one of x squared comes out more narrow. So the best way to explain it to me is it makes it taller. And for a graph that would have not gotten tall, it becomes wider. For a graph that Here, it becomes actually more narrow. So you tell me, I wanna know, if f of x, where is f of x? Alright, it doesn't even have what f of, oh, is f of x x squared? What is f of x up here? Oh, it's absolute, okay. First off, what shape does an absolute value graph have? A V, very good, it's a perfect V. So if I take that absolute value graph and I multiply it by 3, what's the graph gonna look like? Taller, good, a skinnier V, if you will. So this one would be taller. What would happen here?
Still tall, but not as tall.
It'd be in between, right? Good. What about here? Wider. What about here?
Even wider.
Inverted.
It would be inverted and in between the two. Okay? Very good. Hasta la vista. Vaya con Dios. Toodaloo. Kaka. Arrivederci. Smile a lot. Ciao. Arrivederci. Adios, amigos y amigas. Garush, Kadafis. Remember, if you didn't finish your corrections, get them to me tomorrow.